I know I kind of said that the previous video was the last one, but you know I wouldn't leave you without a few more calculations. So here is the only example we're going to look at. We've got a capacitor, we know the plate size or the area of the plates. We're charging it through a resistor and we want to find a whole bunch of things. So first thing is at the instant that the battery is connected, we want to find the current into the plates. Well, the current is at a maximum when it's first connected, and then essentially the capacitor starts pushing back on the battery and the current goes down. But before the capacitor has any charge, the current is just given by Ohm's law, so we can just use V over R. And they give us V is 70 and they give us R is 2. Don't even need a calculator for that one. 35 amps is the initial current in this thing. Part B, we want to find the rate of change of the electric field. This is still applying to the sentence at that instant. So we want to find the initial rate of change of the electric field. So we're going to start out by saying, well, I know Q is equal to CV, and I know V is equal to ED, and I know that C is equal to epsilon naught A over D. So if I plug all of those things in, I'm going to get epsilon naught A over D times ED. And we kind of went through this in the last video, but maybe you didn't take notes, or maybe you forgot. So we end up with epsilon naught AE. And that's equal to Q. So we can take the derivative of both sides, and we get dQ dt is equal to epsilon naught A times dE dt. This is what we're trying to solve for, is the quantity dE dt. And dQ dt, I don't know why it always does that. Anyway, dQ dt equals I, so I can say that my rate of change of electric field is equal to I over epsilon naught A. I was the 35 amps from the first part. Epsilon naught 8.85 times 10 to the negative 12th, and then we multiply that by the area of the plates. Now this is centimeters squared, and so you have to move the decimal 2 places twice, or you divide by 100 squared, so that is going to give us 0.01 meters squared, and multiply all that stuff through, and we get pretty large 3.95 times 10 to the 14th volts per meter per second is our initial rate of change of our electric field. Part C, we want to find the magnetic field in between the plates. I'm going to jump up over here. We're going to start out by thinking about B dot dl is equal to mu naught epsilon naught, so our new modified version of Ampere's law, again throwing out the conventional current term because there is no current between the two plates, and we're trying to find the magnetic field between the two plates. So we have this here, and B dot dl, we're going to do our ring around the plates. Let me draw the plates down here. So we've got these two plates that are our capacitor connected to a resistor and then connected to a battery. So I'm going to take my Amperian loop right around the plate there. So that's going to give me B times 2 pi r, where r is the radius of the plate, which we don't actually know, but we know the area and we know that they're circular, so we can get there. Then we're going to have mu naught epsilon naught. Now this electric flux here is E times A. A is constant, so I can pull the A out. I'll just call it A for now, and then we'll be left with the rate of change of the flux, which we know. Now this A here, we could just plug that in and do a side calculation and solve for R, but we could also plug in pi r squared for A. Then we can cancel out our pi's and one of our r's. We still need to do a side calculation for r, but then we're only plugging in one thing. So we're going to get B equals mu naught epsilon naught times r times dE dt all over 2. So I know that I've got pi r squared is equal to 0.01. So r is going to be square root of 0.01 over pi. So if I plug all of these ugly things in, 4 pi times 10 to the negative 7th, 8.85 times 10 to the negative 12th, and then root 0.01 over pi, and then d dt is going to be this guy, 3.95 times 10 to the 14th. I'm going to divide this by 2, so I can make this a 2 here. And at long last, we get 1.24 times 10 to the negative 4th Teslas is the magnetic field induced between the plates of the capacitor. That's it, so no seeing you next time. It's been fun.